Hello everyone, welcome back to our channel. This week we are going to be answering a question on algebra, relations, functions and graphs, specifically from the January 2021 paper 2 past paper. Okay, so we are looking at question 8 of this question, part A of which asks us to find for the straight line graph of x is equal to 5 minus 3y, which intersects the x-axis at P and the y-axis at Q, determine the coordinates of P and Q. Okay, how do we do this? Alright, so the first thing that they told us is that it intersects the x-axis at P, which means that at this intersection point, y is equal to 0. And then where it intersects the y-axis, x is equal to 0. So automatically we have half of the coordinates for both P and Q. Okay, because I know we'd also have to find the y value for where the y-axis, where this graph intersects the y-axis, what I'm going to do is make y the subject of the formula just to make it easier later on, and for another reason I will explain shortly. Okay, so I'm just going to rewrite this by just flipping the equation around. So now we need to make y the subject of the formula. So let's move 5 over to the right hand side, and as usual when we're moving something from one side of the equation to the other side, we need to do the opposite of what we were doing on the original side. So we are adding 5. This addition of 5 is understood, we just don't put the plus sign. So when I carry it across, it's going to be minus 5. So now we need to move the minus 3, which is being multiplied to y. So when I carry this across, we are going to be dividing by minus 3. So I'm just going to write it like this. In this case, it will be equal to plus 5. So why did I write it like this? Plus 5 over 3. Sorry. So if you would recognize, you may recognize that this is written in the form y is equal to mx plus c, which is the general equation of a line. And m is the gradient, which is not particularly relevant for this question, but what is relevant is c, which is the y-intercept. Okay, so this is exactly what they are asking us for the y-intercept. So in this case, where it intersects the y-axis is at point Q. So just looking at this, once you put this equation in this form with a coefficient in front of x and then a constant, in this case it's 5 over 3, then I know that the y value for where it intersects the y-axis, because that's what the y-intercept is going to be 5 over 3. So let's look at this point P now. So we already know that y is equal to 0. So all we need to do is find x. Okay, so let's substitute y is equal to 0 into equation, which is, okay, so then x would become 5 minus 3 by 0, which is just 5. So x in this case is equal to 5. So therefore, for the coordinate P, the point is going to be 5, 0, because remember we already had y is equal to 0, and for Q, the x coordinates, the x value would be 0, and the y value would be 5/3, and this would be our coordinates. For the second part of A, we are asked to calculate the length of PQ, giving your answer to 2 decimal places. So the length of PQ is going to be the distance between these two coordinates that we have already gotten. P is 5, 0, Q is 0, 5, 3. Okay, so I took the liberty of writing the general equation for the distance between 2 points. That formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. For you have a point labeled point 1 and a point labeled point 2. That's where I'm getting x1, x2, etc. from. So we have P and Q here, so it doesn't really matter which one is 1 and which one is 2. So I'm just going to call this one 1, and Q I'm going to call 2. Okay, so now all we're doing is substituting the x values and the y values here. So So x2 in this case would be 0 minus 5, and that's going to be squared. And then y2 in this case is going to be 5/3 minus 0, and that's going to be squared as well. So that simplifies to minus 5 squared. I'm just going to write it out, plus 5/3 squared, and of course that simplifies to the square root of 25 plus, and I'm just squaring the top and the bottom here, the numerator and the denominator, so I get 25 over 9. So when I work this out in my calculator, my answer is 5.27 units, rounded to 2 decimal places as the question has requested. So for the next part of the question, we are asked to find the midpoint of PQ, which is R. So we need to find the coordinates of R. So there's a formula for this as well. The general formula is the midpoint is equal to x1 plus x2 over 2, y1 plus y2 over 2. This will be the midpoint coordinates, okay? So again, we're just going to leave P as 1, and we're going to call Q as 2. So the midpoint here, you just substitute in the values. You'd have 5 plus 0 over 2, and then 0 plus 5/3 over 2. So this simplifies to 5 over 2 and 5 over 6. So R would have the coordinates 5 over 2, 5 over 6. Okay, so for part B of this question, we are given two functions, fx and gx, and we are told that where these two functions meet would be points m and n, and we need to find the coordinates of points m and n. Okay, so how do we do that? Well, automatically, if we know that this is where these two functions meet, we know that this is where these two functions overlap. So we know that we are automatically dealing with simultaneous equations. So we have two equations, equation 1, equation 2. So let's rewrite it below. So we have y is equal to 5 minus x here. So we'll call this equation 1. And the next one is y is equal to x squared minus 2x minus 1. And we'll call this equation 2. So let's substitute equation 1 into equation 2. So that would give me 5 minus x is equal to x squared minus 2x minus 1. So I'm just going to shift things around and get all the x's together, etc., so that we can solve this, because we are dealing with a quadratic equation, which you see with the squared here, which means that we are going to need to factorize this. Okay, so let's start moving things around. So I'm going to move the minus x, the 5, let's move the 5 first over to the other side. So that's going to give me minus x here is equal to x squared minus 2x minus 1. Because I'm adding 5, it's understood that it's a plus 5 here. It's going to become minus 5 on the right hand side. And then let's also move minus x over to that side. So that leaves me with a 0 on the left hand side, and I get minus 2x minus 1 minus 5. Because it's minus x here, I'm subtracting x on that side. I'm going to be adding x when I bring it to this side. So putting all the like terms together, I have x squared minus 2x plus x minus 1 minus 5. So when I simplify that, I get minus x minus 6. All right, and this is equal to 0. So now this we need to factorize. So how do we factorize? So the method I like to use, I call it the x method, is like this. So if you think about it, let's just take a detour for a second. If you have a quadratic equation, this is the general form of a quadratic equation here, ax squared plus bx plus c. where a is just the coefficient of x squared, b is the coefficient of x, and then you have a constant c, right? When you draw an x and the top numbers here, we are going to put two numbers that when multiplied together would give me x squared. So that would only be x and x. Okay, so this gives me x squared. Now we do the same thing with the bottom here. But the two numbers we're going to put at the bottom of this x would be two numbers when multiplied together would give me minus 6. So make sure and pay attention to the signs here, okay? It's going to be minus 6. So let's try minus 3, and we're going to try 2. Minus 3 by 2 gives me minus 6. One of them has to be a negative because it's a negative number. So then we multiply vertically. Right? X by minus 3, that's minus 3x. 2 by x, that gives me 2x. So now we add these two together. Does minus 3x plus 2x give me this middle term? We want to make sure that when you add them together, it's going to give me minus x. Yes, it does. So therefore, when you factorize this, you just go along the strokes here, right? So the first one is x minus 2, which would be this first stroke. Now we're going to do the other one, x minus 3. So the stroke connects what's in the same bracket. Okay, so now we have factorized that. So it's x minus 3 and x is actually x plus 2. Okay, so, and this is equal to 0 here, which you might, I'm just going to flip it around. It doesn't really matter, but I'm just flipping it around anyway. It's equal to 0. So this gives me x is equal to minus 2 or x is equal to 3. So now we have two possible values of x. So all we need to do now is find y. Okay, so we're going to use equation 1. We're going to substitute x into equation 1, and we have two x values. Okay, so let's do the first one. When x is equal to minus 2 and when x is equal to 3, so let's do this. When x is equal to minus 2, y is equal to 5 minus minus 2, which is equal to 5 plus 2, which is equal to 7. And when x is equal to 3, y is equal to 5 minus 3, which is equal to 2. So we automatically have an x value and a y value for these two meeting points, m and n, right? So our coordinates of m and m would be minus 2, 7, and then let's do the other section here, which is 3. X is equal to 3 and y is equal to 2. And 3, 2. For part C of this question, we are given a speed time graph. So on the y-axis, we have speed and we have time on the x-axis. And what it's showing us is the cycling speed of someone named Monty. Okay, so if you look at the graph, what you're seeing is this flat line here. This represents Monty traveling at a constant speed because it's a flat line. It's not going up or down. But at 4.5 seconds, the speed starts to decrease, and it decreased steadily until 7 seconds. So this is the point when where he's decelerating. And the part 1 of this question asks us to calculate the constant deceleration. So how do we do that? Well, if you recall, the acceleration, what that means is equal to the change in speed over time, or the rate of change of speed relative to time, which some of you might recognize in this case would be the gradient of your speed time line. And how do you find the gradient? The formula for the gradient of a line or between 2 points is going to be y2 minus y1 over x2 minus x1. So what are the 2 points we are talking about? The 2 points are going to be right when he starts to decelerate and when he stops entirely. Okay, so what are the coordinates of these 2 points? So the first point, let's call this point 1. Let's call this point 2, and we're going to call this next one point 1. Okay, so the coordinates of this one is going to be 4.5 on the x-axis, and it goes up to 12. So 4.5, 12. And then the coordinates of this point here is going to be 7 on the x-axis, and of course it's 0 on the y-axis. So there we have it, our 2 points, and I already labeled them 2 and 1, and this is all we have to do is substitute it into our equation now to find the gradient. So the acceleration is equal to the gradient between these 2 points, which is equal to, in this case, we're going to do y2 minus y1, which is 12 minus 0 over x2 minus x1, which is 4.5 minus 7. So this gives me 12 over negative 2.5. Right, so this works out to be minus 4.8 meters per second. But notice what we just found. We found the acceleration, and it's negative because acceleration has magnitude and direction. So the negative sign means that it's decelerating, whereas if it was positive, it would mean that the cyclist in this case would be accelerating. But they asked us for the deceleration, not the acceleration. So because it's already the deceleration they're referring to, the answer would be equal to, you just say positive 4.8 meters per second. But again, if they had asked you for the acceleration, because he's actually decelerating, it would have been minus 4.8 meters per second. So for the final part of this question, we are asked to calculate Monty's average speed over the 7 seconds. So I'm just going to write on top here because this is where I have more space. So if you recall, the formula for the average speed is equal to the total distance covered over the time, this is an L, over the time taken. So let's start with the bottom. What is time in this case? The time taken is simply from 0 to 7 seconds. That was the entire trip. So the time is 7 seconds. Now we need to find the total distance covered. So the total distance covered, because this is a speed time graph, if you find the area underneath this curve, this area here, well, this graph, like if you find this area underneath here that I'm outlining here, this area is going to be the total distance covered. Now you might recognize that this is a trapezium. A trapezium has 2 parallel sides. It's 4-sided, and it has 2 parallel sides, which should be this one and this one. And there's a formula to find the area of a trapezium, and the formula is, I'm going to write it here, area of trapezium is equal to a half side 1, parallel side 1, that is, parallel side 2, multiplied by the height of a trapezium. So if you substitute those values here, this is going to give you, you're going to get a half. In this case, let's look at the top here. This length is 4.5 seconds. And the bottom parallel line is going to be 7 seconds long. And of course the height is going to be this distance here, which is 12. So when you work this out, what you're going to get is 69 meters. So now we know that the distance is equal to 69 meters. So therefore the average speed is going to be distance over time, which is equal to 69 over 7, and that gives me 9.86 meters per second. And this is our average speed. This brings us to the end of this question, to the end of the entire question 8. Thank you for watching, and we hope to see you back here for our next episode.